Yeah, so this is what I prepared, agentic automation. So building inclusive agents that support underdeserved communities. So agentic automation, I say it's a software or it's a process whereby when you're it's giving a goal rather than a script. So let's say a process, most of us know, let's say in acting, there is a script. You actually follow the script. Let's say, go and bring me this bottle of water. You go and bring that bottle of water. But with agentic automation, you give it a goal. It's a process of giving an agent, a computer agent, artificial intelligence agent, a goal, and it works out its own steps. It can call tools to get it done. You just give it a goal. For example, go and get me this water on this water. You don't tell the agent where the water is. It figures out where the water is. If the water is on the table or on the chair, basically something like that. That's what I would call like an agentic solution, an agentic automation. And the goal is to build agent that supports underdeserved communities. Yeah. Um, So with underdeserved community, when we talk about underdeserved community, everything we talk about is accessibility. Everything we talk about accessibility. Um, what will I mean, Mr. Professor Pati talked about accessibility earlier, but I want to um, brief give us a small brief on how I also think about accessibility and how it applies to agents. Mm. So how I see accessibility is not something you vote on or you decide after building a product or an agent. It's something you build a product with it. It's something it's something you think about when you are building a product. So let's say these are kind of the five things kind of you have to perceive when you have to understand. It has to be in you when you are building a product for an inclusive product. So perceive can when they say perceive, can the person you are building this product, can your users perceive, kind of understand the content at all? That is the text, the speech, the document, or even the screen. We talk about navigate. Can they also use the mouse? Can also fill the forms? We talk about contribute. Let's say a person is filling a form. Can the person submit the form? Can the person publish the form? And also, um, the understand is quite understandable. Kind of that's so, one thing to know, some products kind of will pass all of these steps, 3 points, but they will fail, or maybe they can people can't contribute to it. That part, I believe, doesn't make the product accessible. So in the case of inclusivity, so I also think if you use our ability as a baseline, if you use our ability, let's say you as a developer, you as a person building the product, if you use your own ability as the baseline, um, we make it means it makes the product easy for some of us, but not everyone, because we actually don't know the type of people we have all over the world. There are different kind of people, and I believe if we use ourselves as a baseline, we get to exclude a lot of people. So I also believe there is no such thing as a normal people. The interactions and technologies we design or build depend heavily on what we can see. That's the vision, and what we can hear. That's the sound, and what we can touch. Probably the the screens we can touch. So when we assume when you assume, when you are building a product and when you are building an agent, and we assume for every user, the person that will use our product has all these abilities, we create the potential to ignore a lot of a good amount of people in this universe that can use our products. Yeah, we'll go on to the next slide. The inclusion value. One thing I can say, designing an agent for inclusivity does not open the product to more people. It describes people as they truly are. When you design for inclusivity, the how can I put it? The product should hold on. One minute, I'm coming. Guys, I'm back. So I'm talking about the inclusion value. So when you are designing agent for inclusivity, that opens up our product to be used by a wide range of people. And I believe all humans are growing and changing and adapting. Every decision we make when we are building an agent shouldn't be based on what we can do, but it should be based on the general people. Yeah. So before I continue, we go into the agentic world. I want to ask one question, like what's one task probably in your projects that you feel like a human repeats you repeat it multiple times over and over and over again. I believe we can start with this question. One thing in your daily lives you believe you do it over and over again. Yeah. Am I audible? Give me a thumbs up.
Yeah, you can hear you.
Okay. So if anyone wants to answer maybe a task, something you feel like he performs it over and over and over. Hi, nice to meet you.
Yeah, hello.
Um, yeah, hello.
Yeah, Mr. Labi. So I think one task in our project that we have been doing over and over and over again is collection of transportation data. So what we have been doing over and over again is that most of the times we are looking to collect the transportation fares on trotro, taxis, so that the ordinary person who is navigating around the city will be able to have information readily available to do that. But sometimes we end up doing the same data collection like multiples of times because the data gets depreciated or there's a change in data and then it goes all over again.
Okay, that's good. Can we get another answer? Another answer. One last answer so we can proceed. Yeah. Since I have to share my slide, I one last person. or you guys don't have any tasks that you repeat over and over again. So I mean, the best place and cheapest place to look for automation is a place whereby there is a lot of repetition. You give a perfect example, and I believe it's a place an AI agent can help in. Yeah, and so we can proceed. Um, Another thing I would like to ask is like, what makes an AI system actually an agent? Um, what makes an AI system actually an agent? Is someone able to give us, even though I'm showing it on the slide, someone able to give us something on his mind? Yeah.
I think what makes an AI an agent is more of like when you give it a task, you trust it that it's like when you give it a task, you know that this agent is very good in this field. So you're not worried about that. You're not worried about that. Maybe it will go bad or something. It could go bad, but then you have this expertise that he has this expertise in this way. So if I'm using an AI agent to deploy my app online, I'm always assured that he knows how to SSH into the server and then git push and deploy.
Okay, so basically, your AI agent is able to plan. It takes the goal like to deploy your website. It takes maybe your credentials to deploy your website. What should I do? Oh, I have to get the credentials. That's steps one. That's in the planning phase. I also have to be able to SSH into the server. So after getting maybe the server credentials, how do the AI agent during the planning phase, how do I SSH into the server? So it's, okay, there's something I have to do. I have to SSH into the server. How do I do that? Are there tools I need to do that? Or are there packages I need to do that? Okay, it finds the packages that it reaches out for tools. So that's the first thing, that's the planning phase. It reaches out for tools, maybe the packages that it will help it reach out to the server. Um, what I have it also stores and happen what it does. Maybe today, maybe let's say today is Tuesday, you ask your AI agent to deploy your website on your server, and the current changes like you added a new co-founder, you want to add a new co-founder to your landing page, and tomorrow, let's say you were able to raise some funds. You're able to raise some funds, so you want to update your website. Since the AI agent has been did it yesterday, let's say yesterday, it remembers, it stores what it did and the errors it has, so that when it's adding the funding information to it, that doesn't have to go through the long planning phase. That's one thing. Yeah. So in this case, we can see an agent takes on a goal, works out its sequence of steps, and reaches for whatever tools it needs to finish the job. That's what I'll call an AI agent. So yeah. So I want us to talk about automation. Automation is actually evolving. So past time, during some few decades ago, we have RPA, robotic process automation. So it's where a software robot follows rules. You wrote, let me structured data only. It's actually fast, cheap, and actually precise. With this kind of automation, it breaks the moment a process changes. Probably, let's say, after a successful, after, let's say you have a website where people signs up. So it's kind of robot with RPA. Let's say after a user is successfully created the account, you send the message. You send the user an SMS. That could be like that. That could be classified as a robot, as an automation tool. As soon as the user signs up, you send the person an email. Oh, thank you for signing up. So that's classified as an automation. So with something like this, it breaks, or maybe it breaks as soon as there is an error, as soon as the process changes, as soon as there's a change, then we further move to kind of AI powered automation. So this gives robots some senses, as Professor Apati was saying, with the OCR that can be classified. Maybe you take a picture of your ID card. The OCR reads the information on your ID card. It gives it to you have a natural language processing model to that reads can read the tone of your complaints, describes if an email is a spam or a ham, and flags it. That's also a form of AI automation. And in this current era, we are currently at agentic automation. Agentic automation kind of changes changes who chooses the steps. In this case, the agent actually chooses the process it should follow. The agent plans the path, calls the tools, and decide what to do next. Example, an agent can guide a blind person, a blind user on your website or on your product to do his KYC or KYB, know your customer or know your client or know your business. You have a product that requires maybe the SEC requires all your users to perform a KYC. And in this case, you design your product in a way that you assume everyone can see, everyone can see. You know, though maybe you see clearly, but some people need some aids, probably spectacles, and maybe there could be a time where someone is filling the form, but the person is not having his or her tools to spectacles to be able to see clearly, so the person won't be able to fill the KYC. The person won't be able to do the job. So that's where agentic automation comes in.
Mr. Mohammed,
Yeah.
please, are you sharing your screen?
Yeah, I'm sharing my screen. How long could you guys couldn't see my screen?
No, I actually just noticed it, and I see someone had also commented in the chat.
Oh, sorry. Can you guys see my screen? Hello?
Yes.
Yes, sir.
At what stage were you guys not seeing my screen? 4, 5. Wow. 4, 5. That's a lot. 4:22. You can't see your screen. That's like 20 minutes. Can you guys help me at what stage you guys were not able to see my screen?
I think you can continue since they would eventually have the slides and the recordings.
Slides, yeah, okay.
All right.
Sure. So we talked about what an agent is. So in the morning, there was an example that by my colleague, Professor Apati. So from the computer vision helps you to see the world, and the AI agent helps you to act on what you've seen. For example, when you have a blind person when you take a receipt of a payment you've made, the computer vision, when you take a picture of it, the computer vision scans it. You have an OCR model that scans the information you have on the receipt. You can have an agentic tool to reason about the data or the information on the receipt and act safely upon the receipt. If this is a valid receipt, that it contains all the necessary information, can we approve this person this receipt? So with AI agents, we move from just seeing from just seeing to you see and act on it. Yeah. 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 So there's a quick question with a quick question to the guy who asks about storing, getting information, the first information. So it's a general question to everyone. Let's say you have an agent or agentic system. So on the first run, the agent was able to perform the task. So what would you do differently on the next time you want the agent to perform the task or similar tasks again?
Could you repeat the question?
Okay, so you have an agent or an agentic system that performs the task for you on the first time. On the second run, what would you do differently? Let your agent do differently when the agent has to perform the task again the next time.
Is it that the agent is going to have memory so that it won't always go back to ground zero, and then it has some background of context?
Okay, that's a good thing. Yeah, memories are good things. Yeah. Anyone?
It should be able to understand what a change is. So I'm seeing in your slides that there's something like state. So it should know that something has changed from A to B and then how to work on that.
That's good. That's good. That's good. So basically inside an AI agent, when you are building an AI agent, your agent on the first time, your agent should be able to set a goal. Um, set a goal like set a goal. For example, when you give it a question, oh, complete this application for me. So that's one goal. That could be the goal. A user will give it maybe a prompt, a long prompt, and based on that prompt, the user will set a goal for that prompt. The next thing the user has to do after setting the goal, the user has to kind of perceive, understand the goal. The agent has to um, read and understand and pull all the records pertaining to all the information pertaining to that goal. Um, the next one will be to reason, reason, reason. That's where the AI model comes in. The AI with the agents, with the help of the AI model, the agent will reason about all the goal it wants to achieve. Yeah. For example, let's say you are a blind person and you have your card. You have maybe you've written down your information, your address information, and you are filling a form on the website. But your information was written on a piece of paper. Probably maybe a friend wrote that information for you on a piece of paper. But the website requires maybe the friend wrote your name, your last name, your first name, your last name, and the friend didn't write your age, but the friend also wrote your address. But on your website, it recalls your age. You get me? It recalls your age, but here's the case: when you upload the information, there's a missing age. So with the reason parts, with the help of the model, it will be able to determine the missing part of that data. So that's one part something something that every agent has kind of most of the time we have an LLM, large language model, but it could be any artificial intelligence model. Yeah. So that's part. That's one. Another thing is like execute. So in this case, the agent can ask questions in the user's language, ask questions either by voice or kind of prompt. Since the user is in this case is blind, there could be a voice prompt. Oh, okay, there's a missing information. So probably the user can come in and let someone also help him with the writing of that missing information. So the person can snap the picture again, the document again, and send it to put it on the platform for it to be filled for him. Okay, so inside an agent, the agent also is always learning. So in the learning phase, we describe as is there will be a state. So there will always be like store the user's needs, maybe the prompts and the documents, so that when there is similar action that needs to be taken, the agent will be able to do it very quickly and without any hesitation. So mostly the learning part comes hand in hand with the states. An AI agent to have tools, a list of kind of an array of tools it can use. Probably like the guy gave an example of wanting his AI agent to kind of deploy his website for him. So there will be tools for maybe SSHing into your server. There will be a tool for, let's say, if you upload a document, there will be a tool for OCR to get the information on a picture. So let's say you upload your picture. Firstly, the AI agent will determine if you should use this tool or not. So in this case, when you upload a picture and you're supposed to get information on your ID card, the AI agent won't call the SSH tool. It will call the OCR tool. You get me? When you have an agent that kind of translate from the Gbani to Ewe, the AI agent won't go and call the OCR tool. Your agent should also have states. When you talk about states, when you talk about states, you say what has already happened and where the agent stops. And let's say the agent wants to continue from let's say you build an agent whereby users are able to fill forms. It's a multi-form system. So let's say the user was filling a form, but in the case I gave whereby there was a missing ID, the agent stopped processing and gave the user a feedback that there was an error or a missing information the user has to provide. So when the user comes back with the right information, your agent shouldn't start from fresh. It should start from where it's left, the state it was previously. So that's one thing. There should also be guardrails. You don't want a situation whereby a malicious actor can circumvent your security, enter your agent, and performs badly, do sort of bad things. You don't want that kind of things to happen to you when you are building agents. So you should kind of set hard guardrails on your agentic systems, approve certain critical actions. For example, let's say you are settling a dispute. Let's say we have a user named Akosia who sends money to Kwame. But here's the case: Kwame said he didn't receive the money, so Akosia decided to contact the MTN support agent. So Akosia decided to contact the MTN support agent, and yeah, in this case, the support agent asks Akosia question, Akosia provides information and stuff. So the communication goes on smoothly and everything. And now there's a proof that there was an error on the MTN system. So here's the case. There's an error on the MTN system. There's proof everything works fine, but you shouldn't let your agent kind of reconcile the situation. There should be a situation whereby it needs human approvals. Your agent should also have fallbacks. Your agent should also have fallbacks. Yeah. So probably this litmus test. So one I will need maybe one or two volunteer. If you have maybe not the idea what you are building for the hackathon, a different idea, let's do a litmus test if actually your project actually needs an agent. Yeah. Can you guys see my screen? I want to confirm again.
No.
You couldn't see my screen?
Yeah.
Oh. Hold on. Wow. Let me share again. I don't know why it keeps on stopping. Wow, now. Can you guys see my screen?
Yeah.
Oh, sure. I mean, if it goes off, I don't know why my Chrome is messing up. Kindly, someone should just prompt me that your screen is not showing, so I can do the needful.
Okay.
Okay, so
But I wanted
can we?
to volunteer.
You wanted to volunteer? Sure.
Yeah.
What's your? Okay, go ahead.
So I want to share my hackathon idea, what we are building for this hackathon. I believe ideas are
Okay.
cheap, it's only execution that works. So we are
Oh, okay,
building
that's good.
an AI co-pilot based on route intelligence systems, where it can guide an average person on which trotro station is closer, which trotro bus stop goes to their destinations, which short direction should they take to a destination or somewhere that they are going to. So we are looking to get more inclusive
Oh,
data, not just tests. We are collecting the mate's voice data, and then they also do hand gestures. Hand gestures, like maybe they are going to circle. You hear them saying circle, circle, and then they are doing their hands like in the circle way, like a roundabout sort of. So we want to use that kind of voice data to help the visually impaired people, and also to the sound for people who are having sound impairment. So that's how we're looking to build AI agents in that field.
oh, okay, that's good. So here's the case. So we can do a litmus test and see if are you okay with us doing this with your project? Is this what you'll be submitting to the hackathon?
I'm very okay. Once we're able to go through it, bring more criticism, it will help us be able to improve the projects.
Oh, that's good. Anyone to take the first question? Is the input actually messy? Is it a straight input, like a structured input? What the users will be getting? Could it be like, from what I'm seeing, there will be voice input. There could be also actually picture or video. The voice could be maybe circle. So you listen for certain keywords, right?
Absolutely, yeah.
Certain, yeah. And you could also be looking for probably maybe a video feed, or always taking a picture or a video feed whereby you whereby you'll be looking out for maybe some hand gestures too, right?
Yeah.
Okay, that's good. So you've ticked the first one. Well, another one too is does the path change from one case to another?
I think so. It's changed from one case to another in the sense that the app it's basically going to serve anybody who wants to transport via trotro or via the public space. But then it would be customized per the user's use. So if you are visually impaired or sound impaired, when you are setting up your account, after you input your phone number, you get the OTP. We ask you that question. If you choose yes or no, then we will have the use case for you and different accessibility and different interface.
Oh, okay, that's good. That's good. Oh, okay. I think the third one doesn't need data or action across more than one system.
Yeah, I think so because we need a lot of data, and different data like traffic data, different data like weather. Because if it's cloudy and then it's about to rain, the trotro people to change their demand. They create a new demand and there's a new traffic in town. And people also like to know which stations are packed or not. So we want to do cross crowd data sourcing by also linking traffic data and then also collecting data from the GPRTUs and the trotros space.
Oh, okay. So in this case, is it going to be like a situation whereby the trotro stations will be inputting the data, or in terms of the GPS for the crowdsourcing?
Absolutely, that's how you're looking at it at the ground side. So we will have people physically at the stations giving us live data, and then people too who are also commuting and just using the app to can also say yes, it's true or it's false, and then even share with their friends to earn more points and then get badges and gamify the experience.
Okay, so that's cool. So with the last question that I have to ask you, do you think there is a judgment call to your project, not just if it's cloudy, do this? Do you think there's something like that?
Yes, because people really argued about the trotro fares, like what is the actual fare? People really argued about that. So we are looking at where, with the judgment score, we're looking to have more quality data so that we can be the source of truth for public transportation information. So I think that's how I'm understanding it from my perspective.
Oh, okay, okay. I think this fair, probably your project actually ticks a lot of boxes. So we can agree that you need an AI agent. So in terms of that's a good project, that's a good problem to solve, that's a good accessible project to solve. That's good. Anyone wants to volunteer, or we move on to the next one? Okay, I believe we can go ahead. So if with people, if you are still in the ideation phase, you've not actually figured out a project. So we look at places where agentic accessibility shows up. Yeah. So in the financial service, and one thing we can do is like extract invoice data. Let's say we can build extract invoice data. I want to give you guidelines, validate it against some purchase orders, start approval, or flag anomalies as possible fraud. That all could be an agent, an accessible agent could come in place in that section. There are lots of parts whereby in the financial service that we can use agents there. Customer resolution, customer support. There are a lot of problems with the customer support that needs the help of an agent. The agent, maybe when a customer needs help support, the agents can gather histories of past report, histories of past complaints, decide the remedy, and close the loop. Actually, the agent closes the loop. We have to make sure we talked about guardrails. If it involves money, you should prevent your agent from initiating or sending money. That stage should be handled by a human. You don't want any misfortunes, any complaints. You don't want the police at your doorstep. Yeah. In IT technical support too, we can also have your agent run diagnostics, bugs, issues to us, and if the agent finds a critical issue, it can escalate or attach context to your team, so your team can actually pick it up very quickly. That's part. Another one, public service delivery. I believe this force public service delivery. Let's say document processing from these are public services like the passport office and the rest. We can think of a place like that whereby we can use an agent. Supply chain and logistics. I believe what our brother is solving falls under this logistics. That's a good problem. We can think broadly and also, yeah. So there with agent development to with agentic system, there are also different reasoning paradigms. So you want to ask yourself, should your agent should, let's say an agent prompts a user prompts your agent or gives a request to your agent. Should the user sees the plan before it runs, or after the plan, the user can see, should the user see the plan and approves it, or after the agent can just take autonomy and finish everything, then brings out the results? So there we have basically different types of reasoning patterns with agentic engineering. So situations whereby your agent kind of think, act, observe, then actually think again. We normally call as operations. React, react, reason, and act in a loop. So in this case, your agent decide the next tool after seeing probably the last result. This can help maybe with our brother's project, whereby when the agent kind of calls a tools to get the weather reports, then if based on that weather report, the weather report is not actually extracted data. Based on that report, your agent can decide, okay, should this goes into should I go into the next steps or not? So if it's rainy, that means okay, I should halt. In this case, your agent will adapt well when the path is unknown. Yeah. So there's also another paradigm, kind of reason without observation. They call it the real rule. So in this case, in this case, the agent plans every step up front, then executes the plan. Here's the situation whereby the user can see and approve the plan before it runs. It avoids redundant costs. It avoids redundant costs and it's far cheaper. So in this case, the agent will kind of have a full plan of how to achieve the goal. agents will have a full plan. Let's say I have to do this plan A, plan B, plan C. Then the agent starts executing that goal. So these are the reasoning pattern you can adopt when building your agentic system. Mhm. So a quick question. How many of you have filled a form like on behalf of someone who could not? Mm. Let's look at a quick case study. Someone wants to answer? Let's say you are working with your grandparent. Currently, the person is not able to. You have to take him to maybe a hospital. The person is not able to fill the form. You have to step in and fill the form. Just give me a thumbs up if you've done that. Anyone? Thumbs up, just a thumbs up. Hide. Okay, no problem. We can proceed. Good. So, okay, let's look at a situation where we are building an accessible public service application agent. Let's say we have a friend called Akosia or Bernard. The person is blind and the person wants to complete a financial service application. Here's the case. This user primarily speaks only T, and this service was designed. This service was designed around English text and visual navigation. Mm-hmm. For the goal for this agent will be to help Akosia complete the task safely, not just answer Akosia's question. Basically, if you are answering Akosia's questions, it will be like basically you having a chatbot. Mm-hmm. So if you build a system which just answers the questions and leaves her without finishing the task, that's basically the system has actually failed her. That's not actually a good agent. So in this case, since she's blind, the computer vision can come in here. The computer vision help the system perceive the information she will provide to the application. Probably she has a form, an ID card. That's an OC. Probably there will be an OCR tool that reads the data on that ID card. She has to upload it. Then the agentic AI will help in deciding and acting. The agents who decide, okay, have you provide all the information that we need to be able to help you? So the agent will also, since the agent knows that this lady or this person only understands P, the agent won't give information, ask questions in English. And since the agent is aware that this person is blind, the agent won't just be showing a prompt on the phone. The agent will just use a voice service to talk to the user. And the agent won't, there are also screen readers in terms of accessibility. And currently, what is being done is like we don't want the agent to read what's on the screen verbatim. We want the agent to be able to describe the user the situation. Oh, you did this because that's why we are requiring this. So that's the kind of communication we want. we would want with this user. Mm-hmm. Okay. In this case, with this problem, the difficulty is actually in the language. Our user actually explains the problem in Chi, and our system, our service is actually built around English. So that's a big problem. That's a hurdle we have to overcome. Another hurdle is the interface. That's one thing you have to think about when you are building agents. The screen, our interface assumes everyone using our system is sighted. So initially, when I was talking about accessibility, I mentioned that we shouldn't design using ourselves as the baseline. Probably we designing the system, we are complete humans. We don't have any anomalies, but we don't live in a complete system. So we should actually design or build agents that cater for all kinds of users. That's good. Another thing, the system. Another difficult thing you should also look up on your maybe document. Maybe the system requires information that's written in images, PDFs, and not just form fields. So we should think about it. Maybe there are tools. There are tools that can read information from an image. We should think broadly. Process probably the first step. We should look at it as if the first step depends on what turns out to be missing. Maybe before the user moves to the next steps in kind of the agent move the user to the next steps, there is a missing information. How do we communicate that? How do we determine that? Yeah. And consequence. Yeah, our agent should have consequence. For example, submitting that information or submitting that form changes a record. So that's a consequence. It's something we have to think about it very carefully. Okay, submitting that information also kind of changes the eligibility or access of that individual. So for what I can say with that is when you actually think about it, when you are building your agent, maybe the first four of the first four I would say are perception and language problems, which is exactly what an agent is used for. But the fifth one, maybe there are consequences. That's basically situations whereby we have to bring human in the loop to kind of that's improvement, something that has consequence. We don't necessarily have to limit everything to an agent. Yeah. Um, so since I was not getting any questions from you guys, any answers. So before you build anything, you build an AI agent. There are things you
I
should
think
be
you had
doing.
some hands raised. You have about 2 hands raised.
Oh, okay. Oh, how do I check that?
I can call them for you. We have Zan.
Oh, okay.
And then we have Godfred.
Okay. Zan, since your name was mentioned first, yeah. Go ahead. Zan? Hello? Yeah.
But not like right after the time, it'll be like 30 minutes, 1 hour. But
Steam wants to buying.
If you are talking, we can't hear you. Hello?
I think we
Go for
can
it. You
move
can
on to
go on.
Godfred. It appears he's not
Yeah, go
ready.
for it. Yeah.
Okay. So my question was about especially onboarding part of platforms. So like when you build on onboarding, most of the times it's just pictures and maybe something in English. So with concerning what you just said in the last slide, will it be more inclusive if there's a sound or like some creative ways to guide other people on for them to also have experience of the platform?
Yeah. Most when you are building onboarding systems, you have to make sure that it's accessible. You have to make sure that it's accessible. Probably your agent, you have to make sure it's accessible. We have different types of users, and the start of my slide, I talked about accessibility. We are all not the same. There are people who use keyboards to maneuver the programs or websites or apps. There are people who use screen readers. So onboarding, some screen readers will read, take them through the onboarding. Oh, this the onboarding. Let's say when you sign up for a website, um, when you sign up for a website and your onboarding flow starts coming up, most of the onboarding flows are like slide. They are one step at a time, one step to the next step. It moves you to various stages. So when you move on the first stage, let's say you have a maybe an agentic screen read agentic system that takes care of visually impaired people. So that system can on the first that system can oh talk to the person about describe, not just read the words on the screen verbatim. It describes what's actually on the screen. So for the person to have the experience as if the person is visually is able to see what's actually on the screen. We can with this AI agent we can actually help people with should I say people with disability or underdeserved people. Yeah.
Thank you very much, sir. Very clear.
Yeah, sure. Very clear. Any other? Is Zan back? Are you ready, Zan?
So I'm here.
Oh, okay. You can ask your question.
All right. So my name is Eric, and thank you very much for what you have shared so far. You have really gone very, very deep, and you have mentioned perception, reasoning. You also talk about tools, state memory, quadrants, and human in the loop. And my question is, so when an agent operating a real production environment where the data, user behavior, let's say this even take MTN or the bank, for example, where this data, the human behavior, the context are constantly changing. How do you determine whether the agent should continue autonomously or should replan or hand the task over to a human? And what metrics would you use to evaluate that decision boundary? Yeah, that's my question.
Oh, okay. That's a good question. So basically, when you are building agentic systems, so in your code, should have maybe guardrails and fallbacks. You get me? So when you should have guardrails or code that triggers these guardrails and fallbacks. So when, for example, um, someone is consequently let's use in a financial system, someone is trying to prompt your agent in a way that the agent can make transfer money to that person. You should have a guardrails or a fallback automatically determine fraudulent action that one when building this agency system, when there's something we can make use of pick or kind of borrowed from the software engineering world, kind of rate limiting. So when the person continuously makes a request, your system should be able to, okay, this person is trying to, at the reasoning stage, when you get the output, this person is trying to maneuver the agent in a way that the agent will comply with his request. So in that case, when that trigger is hit, you just cut in your code, you just cut and return probably I'm not able to give you this request. I'm not able to comply with what you are saying. Yeah.
All right. Thank you very much, sir.
Yeah, sure. You're welcome. Anyone else with a question? Okay, we can move to the next step. Okay. So, like I was saying, before you build anything, we should you should ask yourself these questions and to actually determine, further understand very well what you are actually building. Given the case study we have, for the agents will be built, so there will be a trigger. Akosia, like maybe our user will ask for help with in the application. So in that case, since he's filling a financial service, there's actually a dispute. We have to take the necessary, that's the intake when we are building the most. We are mapping the process that we'll use to build this our agent, this our helping agent, so we can actually help you guys when you are building your own. You have to trigger. The user will trigger a question, kind of will trigger agent. That will be a prompt. So during that trigger, do we have to take some information from Akosia? We can make use of maybe her ID. Do we have to take her ID? That's one. And also what she needs. We should be able to take what she needs actually in her own language, in her own voice. It could be text. If she in this case she's blind, so we can't use text. So it will be a voice. So evidence. We also have to pull evidence in our system, in our agentic system. We should be able to pull evidence of what she's saying she has done. In this case, she's saying she has made a transaction to so and so and so. So we should be able to pull the information from her history. Our agent should be able to do that. Our agent should, in this case, it's a financial situation. I won't recommend your agent being able to kind of reverse probably a transaction, but your agent should be able to escalate. So escalate the problem to a situation whereby a human will come and review and approve the situation. The agent should be also be able to communicate with the user. Oh, okay. After all this process, after going through your situation, analyzing everything, reasoning about it, deciding, calling tools to verify that you are who you say you are, and everything. This is the next steps we are taking, and you communicate the next step to the user. That's yeah. Yeah, that was good. So yeah, we look at some frameworks you can use. We can build your agent system with, your agentic system with. Has anyone picked the framework yet? If you what you are using, if you want to share what you are using to build your system, yeah, you can share with us. So we have LangChain, LangGraph, we have Crew AI, we have AutoGen, Llama Index, and Semantic Kernel by Microsoft. We also have Agno, yeah, Agno with on Python. So these are the tools you can use to build an AI agent. Has anyone here picked the framework or decided on a tool you'll be using to um, build his
We
agent?
have we are using PG Vector Postgres. So we had a lot of data in Postgres already, and then we don't also know most of like these AI tools. So we instead of that, we changed the database into a vector database by making it a PG vector. But then it's still
Oh,
Postgres, and
okay.
then it's embedded, and we have made more of like a rack system, which connects with Olama
Oh,
and then
okay.
Cloud.
That's good, but you can also look into these systems and um, play with it and see how it's best used or if it can help with your system or product.
Okay, so especially I'll check out Create AI. I think it's no code, so that one will be fast.
Yeah, good. Yeah. The slides will be shared with you, so you can, if you are writing it, you can actually come back to the slides too. Yeah. Um, okay, so before you commit to building your agents, you should actually ask yourself several questions. So one is the complexity. Are you going with one agent or several agents? If it's several agents, that's multi-agent system. Who talks to which agent talks to which agent, which you have to decide all of that early. You have to also decide the data privacy and security. What kind of data are you handling? Are you encrypting that data? Yeah, the access control, authorization, authentication. So we also have to decide that. You also have to, if you are a team of three, mostly you guys, if you are a team of three, you also have to decide your team skills and the weeks you have left to build the product. Um, you also have to decide integrations. That's your agent. Will your agent connect to other system, other data sources? Will it get data from other places? You have to decide that, and that will help you. Um, that will help you in building the product. Um, so you also have to decide how well your agent will perform when during the actual hackathon on demo. You also have to decide that. Yeah. Yeah. Mm. Um, so this basically, I wanted us to do a project analysis, but we kind of had a volunteer where we analyze his or her project. Um, so I think this is fine. Yeah, yeah. So one thing you should know is like agents themselves. Three things you should know. Agents are actually for judgment, not repetition. Um, if it's repetition, probably you can have a script that does everything for you. So the agent should help in making decisions. Yeah. So you also have to actually map the process before you write a line of code. You can also feel free to reach out to me or Professor Apati to if you have any question. Yeah. Yep. This is the end of the slide I have. Any question? This time for questions. You should ask questions. Questions. Thank you. Questions. I want like 5
We
to
have
7 questions. There are
Christian Kwabena. and then
Okay.
Zan.
Christian.
Yeah, thank you very much for giving me the opportunity. So I just had one question. I heard you saying the slides will be given out to us. So I wanted to know how, because I don't know any avenue with which the slides will be shared. I don't know, maybe there's a WhatsApp group that I'm not aware of or something, or it will be sent through via email.
I
Okay,
believe via
I'll take
email.
that. Mr. Mohammed,
Sure.
please let me take that. Have you
Sure.
received any email from us which consists of the link to the meetings, the
Yes,
link to the hackathon website?
yes, I have.
In that email, did you see the message regarding referring to the hackathon websites for all recordings and videos?
Yeah.
So why are you asking the question again?
All right. Okay, thank you.
Please, all recordings, slides, all materials you need regarding this hackathon are on the websites. If you don't find it on the website, check our LinkedIn or check our Instagram page. You will find a clue that directs you to where you can find all the details you need.
All right, thank you.
All right. Okay, and Zan, I hope we can hear you now. Okay.
First of all, good evening, everyone, and it's been a great opportunity to listen to all the talks here and learnings. So I wanted to ask, for instance, me and my team were thinking about what we should build, and what happened was we were caught up in between. Are we going to build for the market woman who has no like field of literacy and they don't know how to operate like mobile money apps and stuff, or are we building for the disabled person or the blind person? So what happened was we caught ourselves trying to merge all those two together to solve those two problems, and I don't think we were gaining that kind of similarity, or like we were not gaining that traction there. So I wanted to ask, are we building this technology just to like per se, like we are building it to help them make life better for them, or are you just saying, okay, we are going to build a technology for these people just because they have this disability? I don't know if you got my question. Hello.
Yeah. I get your question. I
Yeah,
get
yeah,
your question. So you mean you are undecided on if you are building the solution for the market woman because they are not actually well informed in terms of literacy level, or the people
exactly.
with disability, or the people with disability.
Yes, exactly.
So them being not well informed, actually literacy level, meaning they can only understand probably P or Fanti or Ghana, is
Yeah.
actually an accessibility issue. So you're
Okay.
actually building for accessibility. So both being accessibility does not mean maybe everything is all right. No, someone's being able to speak only Chi and your system communicates maybe probably in only English, that's also a barrier. You've created a barrier. So in Ghana we have multiple languages, so you can build in that regard. Mhm,
Sure.
mhm.
And
So
just one
accessibility does
last
not
thing.
apply to only disability. Okay, good. Go on.
Okay. That's what I needed to hear. That's what I
Mhm.
needed to hear, because like from the explanations we were talking about, if someone wants to fill a form or a disability, and when you look at it in two phases, we can have someone who is not a disability person, but just that their financial literacy, I say finance, like their literacy level is not up to that stage where they can just look at something and write the answer on a form. And
in the other case, we also have someone with a disability and cannot do the same thing. So I just thought of it in a more unique way. You know, people with disabilities, we can boldly say that 60 to 70% of them have not had the opportunity to get access to the education that we have right now. So if we're able to solve a problem of that accessibility that you're talking about, then we have been able to solve for the people who have like no literacy and also the people with disability. Am I right?
Yeah.
Yeah.
So the thing you should design for it's actually an inclusion problem. So you design for inclusion. It does not only when you are designing for inclusion, it does not only open the product to more people, it describes people as they actually are. You get me?
Okay.
So you build products for inclusion in mind. So here's the case. One user, you want your product to include to be able to cater for the person who can only speak our local language. So you are designing for inclusion. You are designing for someone who is visually impaired. You are designing for inclusion. You get me? So in my slide, I actually mentioned the inclusion value. You get me?
Okay. So okay.
Uh-huh.
Sorry to interrupt again. When you
No
say
problem. Feel
visually
free.
impaired, okay, when you say visually impaired, it doesn't necessarily mean that the person is blind, right? Like, I mean, someone
Yeah.
could have like, I'll not say a normal eyesight, but they will have a decent eyesight, but they are visually impaired. Like maybe when things are closer to them, they can't see it clearly. Am I right?
Good. Good.
Yes. Okay.
Good.
Thank you.
When things that's actually what I mean. Yeah. That's
I
a good
think
question. Thank
yeah,
you for bringing it up. Yeah.
I think all my confusions are clear now. We can um we can get like we have gotten more feedback from here, so we are going to apply it in what you're about to do. And also
Oh,
the
okay.
agent frameworks, yeah, the agent frameworks. I don't know if I was able to meet the slides, but there are different type of frameworks. We have Vessel AI SDK, we have Mastra, and we have a whole different type of frameworks. So is it like we are going to use the one that we are most comfortable with, or we are just like positioned to use only one type?
Okay. So the goal is for you to use the one where you are most comfortably with, the one that it will help you get the work done easily and perfect. So the one that will solve the problem. Let me put it in that way.
Thank you. Thank you. Think
Yeah. Any
that's it
question?
for
Okay.
Okay,
Thank you very much for your question.
we have Eric and Gladys. So Eric, I think you can go first, and then Gladys would follow.
Okay, thank you very much, Madam. So, and thank you for a very good presentation, and a lot has been shared. So, you mentioned something that agents are for judgment rather than repetition, which is really true. And I have a question. So, you also mentioned that we should map the process before writing the code, which is a very good thing. And I'm asking that in a multi-agent system where we have like multiple agents working on a particular task, how do you determine the boundary of judgment for each agent and prevent unnecessary agent-to-agent communication from creating latency, cost, and also unpredictable behavior? So let's say, in other words, I'm trying to say that what criteria would you use to decide whether a decision belongs to one agent or multiple specialized agents, or even simply like a deterministic software? How do we determine each of these scenarios here?
So, if I get you clearly, the question you're asking is, how do you map the task to various agents, right?
Yes, yes, please. And how do you know that this task it is time for this agent to finish the task for the next agent to take over. Like, how do you determine that? Yeah.
Okay, so you can actually have like triggers. Let's say you have a professor agent, and the professor agent, it acts under the hood. The professor has a research agent. There's also a research agent inside your architecture. So we are actually building a tree. So the professor is actually the root agent. So in the professor will have maybe a research agent. So that research agent does research for the professor, and the professor will also have maybe an assignment agent. That agent kind of takes what the professor taught in a class and gives provides an assignment and for the professor to give for each student. So you can what we can have is, I believe this agent frameworks allows you to spawn what we call a spawn other agents, call other agents based on the prompt you give it. So you can, in that situation, let's say the professor comes in and asks a question. Oh, today I went to class. I taught graph theory or data structures and algorithm. So during that class, I was able to cover this section, talk about that session. So you can have maybe some guardrails there that is being triggered. Oh, if the information is about class and topics and stuff, and let's call the assignment agents. Okay, I want you to give me provide an assignment for this what I taught my class today. So that your agent system will be able to determine based on your prompt. Okay, so in that case, we will branch to the agent assignment agent, not the research agent. Or the professor will come. Your agent system. Another example could be like your agent system. In that case, your prompt will be like, oh, I'm thinking about implementing a paper on writing a paper or researching about capabilities in agentic system. How to ensure that when you spawn an agent, it doesn't how to ensure that when you spawn an agent, it doesn't overtakes kind of the authority its parents have through prompt injection and stuff. So I want to investigate. I want to investigate I want to investigate that. So in that case, based on that, your prompt, it's not an assignment and stuff. So that we will trigger, or your trigger will know that, oh, okay, we are calling the research agents. You get me? So it's like a tree. It's like a tree. If it's about this, we call this. If it's about this, we call this. So that's like kind of, you have a meta agent managing several child agents and stuff. Do you get me? Have I answered your question?
Yes, please. But there's one thing that I want to get clarification on. So let's say if the main agent or the specialized, let's take the main agent. If the main agent send a task to the wrong specialized agent, how does the system detect the mistake and so recover? That's where sometimes I have a little issue there.
If the main agents, so your checks will guarantee that you are actually always sending the agents to the prompt to the right agent. You can actually have fallbacks too. You can actually have fallback. Let's say the agents the agent is not giving actually a good structure. Probably when you are giving your agent the task, your sub agent the task, you can actually give it a system prompt whereby it gives you the structure you want the answer to be in. You get it. So if it's probably not giving you something like that, that's not the right thing. So your fallbacks comes in place. Do you get it? Does that answer your question?
I get it. Yes, please. Yes, please. Because I'm sure the fallback will handle the way so that we don't have one single point of failure.
Yeah.
Thank you.
Okay, Gladys, please go ahead.
All right, thank you. My name is Gladys, also from My Creations. I actually pasted my question in the chat box, but let me just Let me just read it out. So you mentioned that an agent should have memory and state. But how do we prevent memory from becoming a source of error? So, for example, if an agent makes a wrong decision today and stores the experience, how do we distinguish useful learned context from corrupted or outdated memory before the information influences future decisions that will be made by the agents? Thank you.
Okay, so you have to design your agent in a way that it only stores approved information. You get me? So you don't just store everything. Oh, okay. You don't just store. Oh, um, today I was asked. Let's say I'm sending you to. You want your. The example I'm trying to give is like I'm sending you to buy me a toffee. So on your way to buy me a toffee, you kind of encountered a friend. That's not something you don't know the store, but when you're asking for the store, you met a friend wearing white dress. Then he showed you, you asked for to him to show you where the store is, and the person showed you the place of the store. You don't have to keep it in memory that you met someone that and you asked for the place, the location of the store, right? What you have to store is the actual location of the store. You get me? So if you're able to achieve that goal, that's when you store the information. So that one, it prevents you from storing wrong memory. And with the state actually helps for, let's say you are not able to finish a task and the user comes back and asking for continuation. For example, I give an example whereby, let's say, when our blind lady was filling her form, the person that wrote the information on the paper didn't add her age. But in this case, our agent prompted her to actually include her age in the picture she uploaded. So here's the case: we want to store that state, that's the missing state. We don't want to when she uploads a new data, start from scratch. We don't want that situation. Have I answered your question, or is it very clear? Is it clear enough?
Yes, please. Yes, please. It's
Okay,
it's very clear. Thank you.
sure, welcome. Anyone? There's another hand up there.
I think that's an old one.
Okay.
All right. So thank you very much, Mr. Mohammed, for this session. I don't know if Prof. Pati is still on the call with us.
Yes, I'm still on the call.
Okay. Please, do you have any additions for us?
Okay, not really an addition,
Okay.
but just one quick thing to pass.
Okay.
It looks like a few of them are still kind of confused about the
Mm-hmm.
scope of work they need to deal with, and that's
Yeah.
very, very important to pay attention to. I'm not quite sure if they all came for the open day. I'm
I
not quite
doubt
sure
it.
if they all came for yesterday's meeting, and I still can't tell whether some of them came for this morning section as well. Now, regarding the person who asked my colleague about which of the two to use,
Mm-hmm.
if you are here in the morning, you realize that the choice of the two is not just convenience, but again, your end user. Who is your target? If your target is using a young phone, then it's not about convenience. It's about whether your model will run on that young phone. So you need to really think through this carefully. It's a competition. So you need to think through this thing carefully. You are competing with over 100 other people as a team. And so if you don't think too carefully to understand a problem, a societal need, you may end up proposing a solution that only solves a skewed problem. And since a competition, then we'll go in for the one who is much more versatile.
Again, being versatile is not a criteria only for judgment, and so you must have a well-defined problem. Of course, a well-defined problem is based on what you are privy to, how much you are exposed to the people around you. So I plead with all of you, spend time to understand your society, your environment, your culture, and people. That's the only way you'll be able to please the panelists. Otherwise, you may have a wild idea, and that wild idea can only serve the need of someone in the West and not someone in a local context. So we plead, because this question came up yesterday and came up today too. So we are pleading, spend some time to understand the enclave you find yourself, so you can get us a very good solution. That's all I have to say for now, and thank you.
Okay, thank you very much, Prof. Patty. Please, before we call it a day, do we have any other questions or concerns? All right, I don't see any hand raised. I'll quickly check the chat. Okay, I think someone said, what if the agents can't see and hear at the same time? Can we have a document for such agents? The question was asked by Victoria Mensah. Is she still on the call? Victoria Mensah.
Yeah. On the call.
Okay, she's still here. Okay. Mr. Mohammed, please.
What if your agents can't see and can't also hear? So in that case, it actually boils down to the problem you are solving. So if you are solving a problem whereby it doesn't require the agents to see or hear anything, I believe that's understandable. You can actually build that kind of agent. Yeah. And like Professor Patti said, you have to think about the community, the problem. You have to think deeply about the community and the problem you are solving. So, yeah.
All right. Please, can we have or can we give our mentors a round of applause? Virtual or for real? Okay, so thank you once again, Mr. Mohammed, and thank you, Prof. Patty, for a wonderful session. I had fun in the morning, and the evening has just been another sherry, or how do they call it? Another icing to my cake. Right. Okay. So teams, we will continue or we'll continue with another session tomorrow. Tomorrow we'll be looking into accessibility and personalization. I don't know what our mentors have in stock for us, if they also touch on assistive technologies, but the category for tomorrow is accessibility and personalization. Again, we'll have 2 sessions in the morning and in the evening. I encourage us to go to the websites and watch videos from the opening of this hackathon, which was last week. Watch yesterday's mentorship session. Watch the mentorship session we had this morning, and you realize that most of your questions have already been answered. Okay, so till tomorrow morning, I wish you all a nice evening. Keep revising and use this time to revise and polish your project idea. We've shared the templates, the abstract templates with you all, and you have ample time to keep refining, ideating before the submission deadline. Bye for now.
Thank you.